Hey everybody, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. Today I have the second of our Top Projects video interviews for 2021. With me are Rey Aldava, Wastewater Manager for the City of Surprise, Frederick Tack, Technical Director with GHD. He's also won several of these Top Project Awards over the years. Greg Armey, CIP Project Manager for the City of Surprise, and David Giannetto, Principal at Felix and Project Manager for this project. We are going to be talking about the SPA-1 Influent Structure Replacement and Improvements in the City of Surprise. So thank you all for being here today. I really appreciate you all making the time, and congratulations also on a WWD 2021 Top Project.
Thank you.
So first things first, could you describe the scope of this project and the community it serves? I think Frederick, you wanted to take this one to kind of set the stage for everything for us.
Yeah, I'd be glad to. So this project was focused at the 18 MGD SPA-1 water reclamation facility in the city of Surprise. Serves a population of just over 170,000 people. And this structure in particular is one of two main connection points that brings raw wastewater into the water reclamation facility. The influent structure itself is fed from a 30-inch diameter and a 48-inch diameter gravity collection sewer that culminates into a rectangular structure approximately 25 feet by 15 feet and about 35 feet deep. That structure had been noted to have operability issues and excessive corrosion and wear in a short term since recently being renovated and improved. So a concern about this is one of two critical links to get wastewater into the plant for treatment to provide beneficial service to the community. So there were two main purposes of the project. One, to establish what the root cause was of this type of wear and potential failure, and then two, to correct that. So the overall scope of the project was delivered in really three phases. The first phase being a condition assessment to evaluate and determine what those root causes were. Second, to plan, design, and permit those improvements to restore that capacity and really build the resiliency that the city desired. And third was actually delivering the construction improvements.
Mm-hmm. So what about the size of the community that it serves? How many people are kind of affected by this project in general?
Yeah, so potentially the population of just under 170,000 people and about 80,000 connections potentially are could be impacted by this project. So as I mentioned, there are two methods to get connections into the wastewater treatment plant, and the majority of the flow coming through this connection. So it's extremely critical during the planning and design phase to collaborate with the contractor, also with the city, to understand what type of temporary bypass, what type of redundancy was needed, and also to actually quantify that amount of potential flow and impact to the community for this project.
Yeah. So I know that you guys, what delivery method were you using for this project? Is there a specific reason why you chose that method over others?
Maybe Greg or Dave, you could speak to
Yeah,
that.
like the JOC, the part of the contractor was pretty easy. Felix has been working with the city for quite a few years, and they're a very dependable and reliable contractor. And we had Frederick was picked up on an on-call. We just, we have a list. We pick them, use them in order, and I think that was Frederick was the next one up the bat, and we just lucked out with these two team players and hit the perfect, hit the daily double, so to say, not the trifecta, but the daily on that one with
Yeah.
these guys. So it was
I'm
perfect.
Yeah, I'm always interested to know how you guys are delivering these projects now, because I know that Frederick has worked on multiple different delivery options, so it's very interesting to me to hear how and why you all choose different things. But getting to the project itself, phase one was all condition assessment, kind of understanding things a little bit more deeply. What kind of tech did you use for that, and what were the types of things that you were able to find?
Yeah, great question. So, like we do with any project, we don't treat them like a cookie cutter type approach. Our first aspect was to figure out just cursory what potentially could we be looking for. So the structure itself is a cast in place structure with a variety of different metal components for isolation and control of maintaining flow through this system, and a series of different access ports. And the structure being basically completely below grade would require a confined space entry. So first we knew we would need to evaluate concrete conditions, steel conditions. So this physical means to measure those, the quality of those systems without getting into advanced technology. However, we did identify and plan that if the ability to gain meaningful results out of those physical techniques of testing the concrete, testing the metal, that there were other techniques potentially possible. First, potentially we would need some sort of 3D laser scanning to potentially reduce the hazard for confined space entry, to potentially map out if we were going to just replace a small number of components. Second, there could also be concrete penetrating, basically mapping the rebar and quantifying the level of corrosion in the rebar. However, in order to do that initial confined space entry, we had to monitor flow over about a week to understand really when was both the low point of flow and the best atmospheric conditions, when there was the least hydrogen sulfide gas present. And then we were able to stage that confined space entry. Now, based on some limitations, we did not proceed with fully isolating that structure. So we went into a live structure safely to perform those initial condition assessments. Upon those findings, we really found that most of the material had lost the majority of its life cycle. So the concrete could not just be repaired, it needed to be replaced. That means all the components also needed to be repaired. So that really helped direct and really stop the condition assessment. At that point, we determined that we need to save money for later design and construction, move forward with looking at alternatives, which led us to an alternatives analysis of about 4 different configurations with a variety of materials, coatings, and components to best fit the needs of the city, both for long-term life cycle, improve ease of operation, and improve resiliency while maintaining performance.
Yeah, it sounds like this was a really extensive part of the process that set you up for a lot of the success moving forward with everything else, because it established the identity of the actual problem and knowing exactly what you could do and what you needed to use to fix that problem. Am I understanding that correctly?
That's correct.
Yeah. So I know that you had kind of mentioned it, like the bypass elements of this project. There were some extensive bypasses needed, and that always presents challenges when you're trying to bypass things. How did you address this aspect of the project? I know, David, that you had mentioned talking about this a little bit, that there were some interesting challenges involved here.
Sure. Yeah. So as Fred indicated, there are 2 main routes to get into the SPA-1 wastewater treatment plant, west off of Litchfield Road, which is where the bypass is set up, and then from the south, which we didn't have to deal with. But on the western side, we had to isolate the existing infrastructure back to 2 manholes that were actually located in Litchfield Road in a lane of traffic. So the bypass actually had to be set up out in the street in order to isolate far enough back to replace the infrastructure that was identified as needing to be replaced by GHD. A couple of the challenges with that is, as many people know, Arizona is seasonal, particularly the city of Surprise. We have a big snowbird population. And so when you do stuff like this, you want to do it in the summer. You don't want to do it in the winter. And then to add to that even more, we have a big city of Surprise has a huge financial impact by spring training. So the spring training facilities in the city of Surprise are located, I'll call it 1.5 miles from this site. So it's a big no-no to do stuff in the traffic and cause any type of congestion when there's time periods. So we need to do in low demand, and we need to make sure that we could get it done in the time period that we weren't going to be in spring training. And a lot of the flow data that the city did have was sort of based upon the flow came in, and they had an Influent pump station, so they could tell you how much came in, but they couldn't really tell you if how much came in from the north and how much came in from the south. So those required 2 separate bypasses. So one of the things that we did early on is we worked with GHD, and we rented some Flowdar units. They use that somewhat like Band-Aid. I'm not sure if Flowdar was the actual manufacturer, but laser flow meters that we put down in existing manholes that were used to try to get a more accurate read on what the flows were coming in from both the north and the south. and then use that data to competitively bid bypass pumping operations to 3 of the bypass subs that we use to make sure that, one of the requirements of doing JOC is that we still get a competitive bid process, good stewards of taxpayers' money. And we were able to get better flow data that allowed us to competitively bid that, make sure we had the right size pumps, not too little, not too much, and that we were able to do that with a competitive price and meet all the hydraulic demands of different elevations and where we were pumping. It was a neat problem to solve.
Mm-hmm. So during that process, Ray, I'm interested to know kind of from your workflow, what was the impact on you and your team as this bypass was happening and all this work was being done? Was there a lot that you had to adjust to help out in that regard, or was it pretty straightforward in what you needed to do?
It was pretty straightforward. We did have to, during their test period of the bypass, make sure that our Influent pump station was dialed in to receive those flows. Because it'd be a different condition, right? So that was quickly locked in, and it was a smooth transition after that.
Yeah, what a big help then to make it so smooth.
One other thing, Bob, that I forgot to mention, we use a technology called SmartCovers, which is some people in the industry are aware of, that we put upstream on the next manholes upstream. They're satellite radio configured, basically level indicators that both GHD and the City of Surprise and Felix were able to get alarming if we saw trending of flows. It was obviously manned 24 hours a day by people during the bypass, but it always feels a little good to be able to look down your phone right before you go to dinner with your wife to be like, okay, the flows are good. I'm not going to get called. I'm not going to. So that technology was pretty key in making sure that all the players were feeling good about the bypass operation.
Yeah, SmartCover. I've heard of SmartCover. And our industry icon last year is actually one of the technical guys who's a VP over there who helped develop a lot of that and bring it to the market. And it was a very interesting product, and it sounds like it's really useful for things like this and just for monitoring in general. But I wanted to talk a little bit about the optimization of construction because that was another area of focus for you guys on this project. What were some of the tools and concepts that were vital for you in regard to this? David, did you have something you wanted to mention specifically on that?
Well, just that one of the things that helped is Felix and GHD do a tremendous amount of work with each other. Fred and I have a very good working relationship. We do work with each other all over the town, our 2 firms and us specifically together. A lot of trust there, which helps a lot when we are offering, our input. But we ended up going with polymer on this project. The replacement of the structure was done with polymer with an outfit called Armey out of Las Vegas, which is geographically very close to Phoenix. And the inverts, both the inlet and the outlet, were very flat. One of the things that we ran into is when we got down in there, we had as-built elevations, but when you're 35 feet in the ground, the as-built information wasn't that great. And it turned out that some of these lines were very, very flat. So because of the way polymer precast is done, it doesn't have the cure time, and because Amarok was so close in Las Vegas, we were able to get down all the way to the pipe, cut out the existing, confirm last minute angles down to 1 degree difference in between what was there versus what was on the shop drawings. Same thing with elevation across the precast, and then give that to them on a Friday and have the structure show up on Monday, again because of our proximity to Las Vegas. So that ended up being really key in our ability to make sure that what we got out there was absolutely correct based upon the actual conditions 35 feet in the ground.
Yeah, and quickly too. That's
And
such a
quickly,
good
yeah.
turnaround.
Yeah, you don't get that very much. So we were lucky in that regard. And man, that polymer precast is slick stuff.
Yeah.
Very, very happy with the way it all turned out.
That's awesome. That's really, really cool to hear. Well, thank you guys so much for talking with me on this and talking through a lot of the stuff that was going on here. Are there any shout outs that you have or for other people who may have worked on the project that you wanted to highlight and the efforts that they've put together on this?
Yeah, I guess to start, before just a couple people, really want to commend, first the City of Surprise. The way they approached this project was not just fix it. It was let's figure out why it went wrong, and let's make choices that really extend that life cycle of the infrastructure, because that's where the real cost in this infrastructure is. So Dave alluded to, some of those optimizations, those were decisions made during design, right? Where the city had an opportunity. Do we build it back in precast concrete with a corrosion resistant coating? And overall, as the team and with the input from Felix and Dave and his team, we made decisions that both provided alternative and innovative materials to promote that long-term life cycle and corrosion resistance. Also improve the speed of construction, allowing Dave to get the construction done in the window that was provided. And the city was really the one, driving that force and decision. So, being good stewards of their infrastructure. And additionally, just in my team, we had a really great construction inspector on our site to support our efforts, David Hilliard, and inspection staff during that condition assessment, including Frank Dubasic.
Yeah. Awesome. Well, thank you guys so much. And for everyone who is watching, stay tuned next week. Same time, same day, Thursdays, 6 p.m. Eastern Time for the next Top Projects video interview.